So, hello everyone, and welcome to episode 7 of our Echoes from the Field series. Today, I'm delighted to welcome Sedat Başar of HSB Energy. Sedat has an interesting journey with Stryde. So, initially, you were a customer and user of the system, and then recently, you've agreed to become our representative in Turkey as well. So, welcome, Sedat. And maybe you could open up by telling us a bit more about yourself, your role, and the work you're currently involved in.
First of all, thank you for inviting me, Mike. I am a geophysical engineer with 30 years experience working in seismic exploration across Turkey and North Africa. Through my career, I have taken on wide range of roles from field positions such as seismic field QC to executive leadership as a general manager of seismic data acquisition company. This journey has given me a wide perspective from field operation to strategic management. I founded HSB Energy about 12 years ago with a clear focus on delivering integrated geophysical solutions from survey design and field operation to data processing and interpretation. My approach has always been solution driven. I focus on understanding the subsurface challenges first and then designing the right geophysical solutions around it. In recent years, we have been focusing more on high resolution imaging complex near surface problems, while also expanding our capabilities in seismic data acquisition using modern high density technologies.
Thank you very much. So, as I mentioned in the intro, you're a Stryde customer who's also recently become our representative in Turkey. What was the turning point that convinced you of the technology's value?
While I was serving a general manager of seismic service company, I came across Stryde while working on wireless systems. To be honest, it was really a research exercise. It was more about finding practical solutions to real challenges. I was already very familiar with the operating condition in Turkey and the limitation of conventional systems. When I looked at Strike technical capabilities, it was clear to me that it could directly address many of challenges like logistic difficulties, geometry limitations, and operational problems. Once I learned more about the advantages of nodal systems, I decided to purchase a small-scale system through Stryde in order to use, especially for mining projects in my company. That steps became a real turning point for me. What I saw in the field, nodal system was part of the solutions itself. I have seen how critical this type of technology can be for operation in challenging environments. That's why I decided to take on the representation because I believe it can make meaningful difference in Turkish market.
Hmm. Okay, thank you. Um, how do you typically optimize the acquisition parameters? So how do you trade off receiver density, offsets, azimuth coverage, etc., to improve imaging in complex terrains?
My approach always starts with subsurface objective. The first question is, what problem are we actually trying to solve?
Mhm.
Firstly, if this question is well defined, seismic field design can be carried out more successfully. Receiver density is a key parameter in complex environments. Low sampling can easily miss structural details, especially in fractured and heterogeneous settings, and it often leads to less stable processing result. Increasing receiver density improves wavefield sampling. This helps with noise separation and velocity model building and also contributes to reliable statics. Offset and azimuth coverage are just as important. In areas like Turkey, where steeply dipping faults and strong lateral velocity variation they are common. Having a well-balanced and sufficiently wide offset distribution is critical for imaging deeper structures and support a robust velocity model. At the same time, good azimuth coverage helps reduce directional bias and improves the elimination of faults and deepening formation. Also, the key point is not simply to acquire more data, but build the right geometry. The receiver density, line orientation, and offset distribution should be designed together. Otherwise, we can end up with a very expensive data set that still doesn't solve the imaging problem. As a result, operational efficiency always matters, but in complex terrain, you cannot compromise on data quality. My approach is always finding that balance.
Thank you. So, from some of your opening answers, it sounds like a lot of people still use what we call conventional seismic acquisition methods, so maybe cabled systems, for example. In your view, what's the biggest limitations of that type of acquisition in Turkey?
One of the biggest limitations is it becomes operational restrictive exactly where high quality seismic is needed the most. Cable-based systems and lower density layouts have bottlenecks in mountain terrains, densely faulted belts, agriculture areas, or location with access and permitting problems. Another important issue is noise handling. In conventional system, receiver areas are often used to suppress near-surface noise. However, in highly fractured and topographically complex terrains, these arrays are not always applicable because they can introduce intra-array statics and degrade the signal instead of improving it. In addition, the logistic of cable system add a significant operational burden. In difficult terrain, this is not only reduce efficiency, but also increase chassis risk. In some cases, this makes these systems impractical or even unfeasible for new exploration areas.
So, how can modern nodal systems help overcome those limitations then, particularly from a data quality and imaging perspective?
Nodal systems are really change what you can practically do in survey design. They take away many of the geometric and logistic limitations that we typically faced in cable system. They make high density acquisition something you can actually implement in the field. From the data quality point, increasing receiver density improves spatial sampling, reduce aliasing, and give us much more stable and continuous data set. That directly helps with noise separation, near surface understanding, and build a more reliable velocity model. In places like Turkey, nodal system also make a noticeable difference in first break consistency. That help us build a more detailed and reliable near surface model. At the same time, since we are not using receiver array, we avoid the intra-array static problems that can be quite challenging in this kind of heterogeneous environments. From an imaging perspective, the flexibility in how we deploy the system gives us much better control over receiver density, offset distribution, and azimuth coverage that translate into better elimination of steps, faults, and complex structures. Another important point is that nodal system make it more practical to acquire broadband data, especially with better low frequency content.
Okay, thank you. So, in your experience, having used Stryde, what differentiates Stryde the most in terms of value and the impact on your work?
I truly believe that Stryde is creating a real shift in seismic industry by simplifying data acquisition to this level. It opens the door for seismic to be used more widely and across a much wider range of applications. It makes field operation much more practical It allows us acquire a volume and quality of data we actually need in much more efficient way. And the impact is not limited to oil and gas. I also see it playing an important role in making seismic more accessible in geothermal and mining projects, where it has been used traditionally more limited. In environments where geology is complex, terrain is challenging, and logistic can be major limitation, Stryde makes high-density nodal acquisition a practically reality. For me, what really stands out, in fact, that it brings together all the key advantage in one system: high receiver density, flexible geometry, wide offsets, strong azimuth coverage, and better support for near-surface modeling. In the end, the real impact of Stryde is about making the right survey design actually achievable in the field. That's what really changed the game.
So thank you very much. And from a geophysicist perspective, what tangible improvements have you seen in interpretation confidence when working with high density seismic data?
The biggest improvement is the level of confidence in structural detail. We get much better event continuity, clear fault definition, and far more stable interpretation of fine discontinuities that directly translates into reliable prospect definition and better well placement decisions. Another key benefit is how it improves uncertainty management. With lower quality data is often difficult to tell whether a problem is geological or simply related to data acquisition. With high density data, that distinction becomes more clear, which significantly improves decision making. It also becomes an important input when planning a new seismic programs. There is also a clear step change in imaging quality with cleaner and more continuous seismic sections, especially areas that we previously interpreted only from a structural perspective can now be evaluated from a stratigraphic point of view. In a working petroleum system, this can unlock additional exploration potential and create significant economic value. In practical terms, this means higher confidence in fault mapping, closure definition, understanding reservoir geometry, and ranking drilling opportunities.
Very powerful. Where do you see the biggest growth opportunities for seismic in Turkey? So you mentioned several industries. You mentioned oil and gas, mining, geothermal, and then there's some other sectors as well. So where do you see the biggest growth coming for seismic in Turkey?
Oil and gas still represents the biggest opportunity, especially in areas where better imaging can unlock additional value from structural complex plays. Southeastern Turkey is a very good example of this. Over the last 5 years, particularly in Şırnak region, production has shown a strong upward trend, reaching levels that are roughly double of country's previous baseline.
Wow.
However, this is also one of the most challenging areas in terms of topography and operational conditions. In fact, a region that currently accounts for around 2/3 of Turkey production has still not been fully explored.
Wow.
At the same time, I see significant growth potential in geothermal and mining. In geothermal, seismic is still underutilized compared its potential. It can play a much bigger role in structural understanding, fault mapping, and building integrated subsurface model. As you know, Turkey is already the fourth largest geothermal power producer in the world, but there is still gap between installed capacity and the full resource potential. That gap will require more exploration, and we definitely see ourselves playing in a role there. In mining, particularly for deeper targets or structural controlled mineralization, seismic is also underused. As exploration moves deeper and targets become more complex, the value of seismic will naturally increase. So in the short term, oil and gas remaining the main driver, but in the medium terms, the real growth story is wider. Looking at it proportionally, I think the seismic studies in the mineral sector will grow even more.
Yeah, I find it fascinating that Turkey is such a huge geothermal producer, but seismic for geothermal is still in its infancy to a degree. Yeah. So last question, what advice would you give to companies planning seismic surveys in Turkey?
The starting point for any seismic project should always be preliminary scout study. That initial step is critical. Once that's done, you need to sit down with the operator's exploration team and align on the regional geology, the petroleum, geothermal, or mining systems, and the specific challenge of area. This process helps us anticipate potential issues early, both in acquisition and processing. This second step is to develop a realistic and optimized survey design that also fits within budget limitation. At this stage, it's essential to balance the imaging requirement with the limitation identified during the scout phase. The goal is to create a practical and economically sustainable master plan for the field.
Hmm.
In the end, it comes down to clearly defining the balance between geological objectives and available budget. You need to be upfront about what level of seismic result can be realistically achieved within that framework, and if needed, after technical discussion, a final scout phase may be required to define expectation before moving forward.
Okay, thank you very much. Is there anything else you wanted to cover which we didn't get to today?
No, thank you. It was very nice talking to you. Thank you.
No, likewise. And I enjoyed the discussion. I think our audience will get a lot from it as well. So thank you very much.